Let us discuss modified Booth algorithm, also known as bit pair encoding algorithm, also known as radix 4 Booth algorithm. All are same. What does it mean? We will see. So the main idea or otherwise main advantage of this modified Booth algorithm is we are going to reduce the multiplier bits. Okay, how it will be done we will see. But end of the day, the number of summands, example, when you are multiplying 2 3 with 34, let's say 235 343, just apply the multiplication, just observe the multiplication. 3 5 is 15, something you get, something something. I don't want to really do the multiplication, that's why I show like this. So you will see three summands, right? These three are called, of course, you know, summands. So these summands are here 3, but in our model, when you multiply 1, 2, 3, 4, 5, 6, 6-bit multiplier with some 6-bit multiplicand, then how many summands you are going to get? That means products. So definitely 1, 2, 3, they depend on multiplier. 3 plus 3, 6, right? 6 summands you are going to get. Of course, some of them are zeros. So in modified Booth algorithm, the target is reducing the number of summands. Okay, so that's why this comes under classification of fast multiplication algorithms. Okay, so because of this step, otherwise because of this modification to your Booth algorithm, the number of summands will be reduced by n by 2. Example, if you have n bit multiplier, then at least n by 2 summands we are reducing. That means generally we will have n summands, then we will be reducing it to n by 2. You will be having at most n by 2 summands, maybe less than that if you have some 0 summands. Okay, so that is the idea. But how that will be, how that will be taken place, we will see. First of all, try to understand your first Booth algorithm. Like in Booth algorithm, what is a recoded multiplier? Let us see that first. For that, let me focus on this multiplier first. 0, 0, 0, 1, 0, 1, right? Then we imagine a dummy bit. I am just observing Booth recode. Okay. So 0, 1, 0, 1, minus 1, right? Now these two, 1, 0, plus 1, then 0, 1, minus 1, then 1, 0, plus 1, correct. So then I can write plus 1 also here, plus 1, then 1, 0 is plus 1, then 0, 0, 0, 0, 0, 0, right? This is the final recode. Now what we are going to do is, once it is done in modified Booth algorithm, then we will be pairing these things. Okay, like this. So when you pair like this, then your base 2 will become base 4. That's it. That means I am taking all the digits of this Booth's multiplier and we will be converting into radix 4. That means take every 2 digits and convert into 1 digit. That's why it is also known as bit pair Booth algorithm. So how to convert, I will tell you. 1 comma minus 1. So because of our model, what we are going to do is we are giving 2 times weightage to this one than this one, correct? That means, so it is 2 to the power of 0, this is 2 to the power of 1 with respect to weightages, isn't it? So that's why if you want to know, just cross check. So what is this value? 5. When I write 0, 0, plus 1, minus 1, plus 1, minus 1, this is actually with respect to weightage system, it is plus 5. Check it out. This is 2 power 0, this is 2 power 1, 2 square, 2 cube, 2 to the power of 4, 2 to the power of 5. 2 power 5 into 0, 0, plus 2 power 4 into 0, to 0, plus 2 cube into 1, right? 8 into 1, 8. 2 square, 4 into minus 1, minus 4, 8 minus 4, plus 2 into 1, 2, plus 1 into minus 1, minus 1. That's why 2 minus 1, 1, 8 minus 4, 4. So here I would like to tell you one thing. So 1 minus 1, this entire value, the weightage of this entire thing is overall 2 minus 1, 1. That's why, so whenever I have 1 minus 1, then I'm going to convert it into 1 digit. That is nothing but 2 into 1 plus minus 1. The weightage for this one is 2. The weightage is 1 here. So it would be 1. This is the way I'm going to convert everything now. Every pair. So 1 minus 1, 1. So 1 minus 1 again. It would be 2 into 1, 2. 2 minus 1, same thing, right? 1. So this is 0. Because 0, 0 is nothing but 2 into 0 plus 0. So in that way, we will be converting 1, 2, 3, 4, 5, 6 digits to 3 digits. This is the multiplier in modified Booth algorithm. That's it. This is very important step. If you know this, then that is enough. Okay, now finally given 0 0 0 1 0 1 0, how to get 0 1 1 is a question. So using our, first of all we convert this to Booth multiplier, then from Booth multiplier by taking every two digits and by pairing them we will be getting 0 1 1. Now this is radix 4, this is actually 5. How it is 5 I will tell you. So you imagine this as 4 power 0 weightage bit, this is as 4 power 1 weightage bit, this is as 4 square bit. Then you will be getting again 16 into 0 0 plus 4 into 1 4 plus 1 into 1 1, 4 plus 1 5, actually it is 5. So we recoded it in radix 4, radix 4 system, that's why you got 0 1 1. So number of bits got reduced, correct? We used to have 6 bits, then we got only 3, that's why number of summands will be reduced. Now what we are going to do I will tell you. Your number is what? 2 power 0, 2 power 1, 2 square, 2 cube. I am talking about multiplicand. Our multiplicand is 10. 10 5 is 50. How we are going to achieve 50 using this model I will tell you. So first we have 10, correct? So we will be multiplying 10 with 1 first. 10 ones are 10. Remember it. So this is one product. The second product we will be multiplying. It is like this. Take 10 in decimal for convenience generally, but we have to take binary. Of course in binary also we can take, not a problem. Do like this. Otherwise let me take binary. What is our binary number? 0 0 1 0 1 0. Okay. Now 0 1 1. Take 0 1 1. But it is radix 4. Remember the difference I will tell you. First of all, multiply your number with radix 1, radix 4 first digit. 1 0 is a 0 as it is. 1 1 is a 1. 1 0 is a 0. 1 1 1. 1 0 is a 0. 1 0 is a 0. So value wise it is 1. But weightage wise it is 4 power 0 weightage number. Now this 1 is actually having weightage 4. That's why if you want to feel like a binary multiplication, then we have to shift 2 times. Okay. So because it has 4 weightage. In binary numbers are having, example, whenever you have a number like this, every digit has 2 weightage, correct? That's why while writing we started writing here. Since here this is binary, try to understand. This is binary, but it is radix 4. Then for same mathematics, if you want to have same kind of multiplication, what you should do is, once I will tell you. First of all, blindly write it 0 0 1 0 1 0, correct? Second time when you do multiplication, since it's a radix 4 number, then we have to shift 2 digits rather than here, because this is having this weightage, the equivalent, the weight of this, the weightage of this bit is 4, right? That's why we have to come here, because in this is in binary, the weightage is 2 power 0, 2 power 1, 2 square. That's why we have to start writing the next summand from here. That's the only difference. Okay, let us do that. 1 0 is a 0, 1 1 is a 1. Same thing you get, right? 1 0 is a 0, 1 1 is a 1. So 1 0 1 0 0 0 you get. Yes, done. Then the last one 0. Now again shift by 2 bits because it's a radix 4 model. So next time the weightage is actually, this number's weightage is 16. That's why we have to go to 16th weightage bit. 2 power 0, 2 power 1, 2 square, 2 cube, 2 power 4. That's why you start filling from here. 0 0 0 0 0 0, right? 4 plus 2 6. Yes. Now add them. 0 1 0, 1 plus 1 0 1. So 1 0 0 0 0. Now we got binary number again. It's base 2 actually. So see the value, 2 power 0, 2 power 1, 2 square, 2 cube, 2 power 4, 2 power 5. 32 plus 16, 48. 48 plus 2, 50. Perfect. So 10 5 is a 50. So that means what? Using 0 1 1 we are going to do the multiplication. For that, what are the precautions we have to take? One, ordinary multiplication, like already in Booth multiplication, whenever you have a 1 bit, in any binary multiplication, whenever you have 1 bit, what did we do? So we simply multiplied. That means we multiplied 1 with 0 0 1 0 1 0. Here also same thing, but only shifting is 2 shifts every time, correct, rather than 1 shift. Remember it. So finally we can implement it, like there is no difference, but the number of bits are only 3, correct? So we reduce, that's why every bit represents one addition, so number of additions will be reduced, right? So that is the idea. To To understand it easily, that means finally, to understand it easily, we'll take one more example. Okay. So here this time multiplier is -7. Okay. So negative number. So start first of all converting it into Booth multiplier 1 1 0 0 1, right? The first step. We add dummy bit 0 0 1 minus 1, right? Next these two 1 0 plus 1 0 0 0 0 1 minus 1 1 1 0 1 2 3 4 5. We got 5 bits. You know one thing, right? Whenever we get odd number of bits, then we can't pair them. That's why we add one imaginary bit here. Okay, so just for convenience. So we, according to sign extension, when I add one more one, there will not be any change. There, that doesn't matter. That's fine. Now 1 1 0. So this is now Booth multiplier. Now we will be taking this and we will be converting this multiplier to modified, the multiplier in the modified Booth algorithm. Let us do that. So here these two a pair, correct? So these two a pair, these two a pair. 0 0, we know 0, minus 1 0. Let's recall 2 into this plus this, 1 into 0, correct? So that is weightages. So it would be minus, always remember minus 1 0 is nothing but minus 2, correct? So you write minus 2 here. 1 and minus 1, if you have 1 and minus 1, 2 into 1 plus 1 into minus 1, which is nothing but plus 1, right? So this is a conversion. Remember one thing, when you have Booth multiplier, for minus 1 what did you do, recall? So whenever you have minus 1 bit, then we just we just multiplied 10 with minus 1. In binary patterns, example, if it is a binary number, then that binary number into minus 1 is nothing but, so the negative version of that binary number. That means it's simply 2's complement of 10, right? If you do 2's complement of 10, this operation will be done, minus 1. So what is the meaning of doing plus 1? So doing plus 1 is nothing but multiplying this 0 0 1 0 1 0 with 1, right? Then again you get 0 0 1 0 1 0. You know all that process, right? Now here, what does this 0 minus 2 1 means? I will tell you. Plus 1 means we have to do add operation, as usual, like plus 1 in the modified, in Booth algorithm. Minus 2 means multiply that m, whatever the multiplicand you have, multiply it with 2. This is extra thing now. Okay. So because we have minus 2, then we should do minus 2m. Okay. So in this step, we will be multiplying the multiplier with 2 and we will be multiplying with minus 1 also. So multiplying with minus means finding the 2's complement. You can do one thing. Take this number, do the 2's complementation. Okay. Then multiply with 2. That's it. Then you can get this effect. Now 0 means no addition, nothing. So let us check it out. Let's try to do that. Already I told you, right? 10 into, first step is what? Multiply with 1. 10 ones are 10. Remember it. So we have 10. Now next time. This time minus 2 into 10. Minus 2 into 10 is what? Minus 2 into 10 is minus 20. Remember it. Third term. 0 into 10. 0 into 10 is 0. So you get 10 comma sum minus 20. I can write from right to left. 0 one term, minus 20 one term, 10 one term. But don't say that, sir, 0 plus minus 20 minus 20 minus 20 plus 10 minus 10. So answer supposed to be minus 10. No, answer should be minus 70. The reason is, so we are not directly adding 10 minus 20 0, right? We will be shifting the summands, right? So you know that process. Okay, I don't want to discuss that, but still for this example I will tell you. So here 10 will be taken as it is, but the weightage of minus 20 result is 4 times minus 20. That means we have to shift appropriately. Whenever you shift binary patterns appropriately, so this minus 20 sum, this value will be multiplied with 4. That's why 4 into minus 20 actually, plus 4 square into 0. 4 square into 0. So you just check it out. 10 plus minus 80, which is nothing but minus 70. Perfect. So this is about modified Booth algorithm. Don't worry too much. Just remember one thing. In modified Booth algorithm, this is important. So how to achieve this First of all, this pattern 0 minus 2 1, that is very simple, right? So using, once you have this kind of Booth multiplier, then we can convert that to bit pair encoding. So this is also known as bit pair encoding. You understood that thing, right? Second thing, so we will see the actions. That means whenever you see +1, what are you going to do? Whenever you have -2, what are you going to do? Whenever you have 0, what are you going to do? Okay. So whenever you see +1, then you will be doing +1 into m. Okay. So that is a summand. Otherwise, your partial product. Whenever we have -2, then we should do -2 into m. Whenever you have 0, then we have to do 0 into m. That means no addition, right? The result of that partial. Otherwise, so in that row, did you remember? Whenever you apply binary multiplication 0 1 1 0 1, recall. So why here it is 1 1 1 1 1 1 0? Why it is 0 1 1? Because here the operation is 0 1 1 into 1, right? That is equivalent to what? 1 into m, right? Now here also next step 0 1 1 we add, but 1 into m, right? So forget about the positional system. If you forget about that positions, so whenever you have 1, we will be doing 1 into m. Whenever you have 1, we will be doing 1 into m every time. Whenever you have 0, we are doing 0 into m, right? Here also same thing. Whenever you have 1, we do 1 into m. Whenever you have -2, you will be doing -2 into m. Whenever we have 0, then we will be doing 0 into m. That is one thing you should remember. Now, sir, how you decide everything? We will be, so this is all our imagination, correct? So how this really 0 -2 +1 can be calculated with just by seeing the multiplier. I will tell you. By seeing the multiplier, we can find out that 0 -1 -2 everything. I will tell you the technique. So that is one thing you should learn in modified Booth algorithm. So I don't want to waste, I don't want to spend much time here. That's why I'm just giving the rough idea. So don't try to understand everything. Only two things try to understand. One thing, are you able to find out that code? That means bit pair encoding. Yes, that is very simple. Second thing you should know about modified Booth algorithm is, so what are the, based on which pattern we will be taking which action. Okay, I will tell you. Example, let's say you are seeing a multiplier 1 1 0 0 1. Now we are not taking the decision based on single bit, correct? We will be taking pairs. So just recall, this is only for our reference. Okay, this is only for our reference. 0, so this is our imaginary 0, this is original multiplier. Okay, but we added one extra one for proper pairings, correct? So 0 1 -1, I am writing it again, don't worry. 1 plus 0 plus 1, 0 0 0 0 1 minus 1, 1 1 0 1 1 0, correct? 1 2 3 4 5 6. Now without constructing this one directly, how to construct that one you should understand. I will tell you. So for reference, I write the previous things. So 1 minus 1, finally we made 2 into +1, 2 +1, right? Now this one is -2 and this one is 0. So finally what I want to tell you is, here we will be observing this 0 1. That means by taking these two as a pair, that is what the story. So for 0 1 we generated +1. For 1 0 we generated -2. Okay. For 1 1 we generated 0. But how to directly generate them? Indirectly using Booth multiplier code we generated, but how to directly generate, I will tell you. So here actually why you got +1 instead of 0 1? So for 0 1 combination, why you got +1, I will tell you. Because actual story was to generate +1. So we were first converting 0 1 to -1, 1 0 to +1. So after that, +1 -1 is equivalent to 2. So because the weightage of this one is 2, this weightage of this one is 2 power 0, 2 power 1. So that's why this is equivalent to 2 into 1 2 plus 1 into -1 -1. So it was equivalent to +1. That's why this entire pair is, this pair 0 1 is converted to +1. Similarly 1 0 is converted to -2. How you see? So actually we have 1 0, but we have reference term 0, right? So using 1 0 0 we converted -2. How you see? So 0 to 0, right? 0. The story behind -2 is first these two terms. So this 0 is because of these two, correct? That's why we have to refer this one also. 0, 0, 0, 1, 0. Sorry, 0, 1, minus 1. That's why with minus 1, 0, we got minus 2, correct? So finally what I want to tell you is the circuit which you are going to design, that is going to observe 2 bits at a time. Okay, by observing these 2 bits along with the next right side bit as a support, it is going to do these actions. So now we'll build a table so to describe all the actions possible in this modified Booth algorithm. Example, let's say currently we are considering this pair of bits. Okay, remember one thing, generally in our multiplication we take every bit and take the decision, correct? But in this one we will be pairing the bits. That means for these 2 bits only one decision, for these 2 bits there is only one decision, for these 2 bits there is only one decision. But how, what is the decision? If you want to know, let us do that. Okay, for that assume that this is ith bit something, this is I plus 1th bit, correct? This is I minus 1th bit. So let us write it. If you have ith bit, let's take I plus 1th bit, ith bit, I minus 1th bit. So if ith bit I plus 1 bit is the pair you are considering, let us say they are 0, 1 and the supported bit is 0, then what is the action we are going to take? That means the action, otherwise also known as that product, right? So also known as the partial product. That action is going to generate a partial product. What is a partial product you are going to take? Is it 0 or plus 1 into m? You know, right? Partial products. 1 into m minus 1 into m depends on this code, correct? So now we will see. Since 0, 1, 0, 0, 1, 0 is finally converted to plus 1, that's why the action is plus 1m. Now what we do is, so we take all possible because this is only for our example, but in the reality the binary pattern can be anything, then any binary combination can be possible for I plus 1 and I. So what are the possible combinations we can have? We will see now. Example, let me write for everything. So first, if I plus 1 is 0, I is 0, I minus 1 0, then what will be the action? Really the bits are 0, 0, I am writing here 0, 0 and the reference bit is 0, that means I minus 1th bit. Then how, what should be first of all this code we will see? 0, 0, very simple, 0, 0, 0, 0, 0, 0. Now convert this 0, 0 to code, 2 into 0 plus 0, 0. That's why the action is 0 into m. That's it. At that time we will be multiplying with 0. Which one? Multiplying. Second one, what if it is 0, 0, 1? Now from now onwards it will be easy for you. So 0, 0, 1 will be converted to first 1, 0 plus 1, 0, 0, 0. So 2 into 0, 0, 0 plus 1, 1. So 0, 0, 1 is nothing but plus 1 into m, right? Next 0, 1, 0. If it is 0, 1, 0, what is going to happen? Now whoever is watching this video, please do on your own. 0, 1 minus 1, 1, 0 plus 1. So if I convert 1 minus 1 is equivalent to 2, 2 into 2, 2, 2 plus minus 1. So 2 into 1 minus 1 plus 1, right? So that's why it is plus 1. Next 0, 1, 1. So 0, 1, 1 is like this. 1, 1, 0, 1, 0 plus 1. So plus 1 and 0 is equivalent to 2 1s are 2, correct? 2. So that would become 2m, right? Plus 2m. Now 1 0 0, 1 0 1, 1 1 0, 1 1 1 I have to cover. Okay, let me cover them. So let us start with 1 2 3 4. 4 are done. Now remaining 4. 1 0 0, 0 0 0, 0 1 minus 1. Minus 1 0 means minus 2m. You know that, right? By this time you should get experience. 1 0 1, 1 0 plus 1, 0 1 minus 1. So minus 2 plus 1 minus 1m. Yes, next 1 1 0, 0 1 minus 1, 1 1 0. It would be minus 1m. Next, last one, triple 1, 1 1 0, 1 1 0. It is 0m, right? So these are the actions. Now what I want to tell you, sir, why are you doing this? So what is the advantage? Now from now onwards, when this multiplier is given, then we will be, this is of course dummy bit, correct? Now we were observing 2 bits at a time and we are taking only one decision. What is that? Plus 1 into m. That means we are doing only one addition, right? Because only one bit we have, right? Similarly, for these 2 bits we are taking only one action, correct? Similarly, for these 2 bits only one action. In that way, the number of actions, if you see, so we used to have 6 actions, right? Now that 6 become 3. That's why number of actions will be reduced. That's why the algorithm will become faster. That's quite easy to understand. So rather than example, let's say if you had to do 6 additions, rather than that we are doing only 3 additions, because we are observing 2 bits at a time and only one decision we are taking, but number of shifts we are not reducing. Okay, we will be continuing the shifts, but the addition part, if you see, generally we used to do at most 6. Example, for this 6-bit multiplier, 6 additions we supposed to do in some cases, but here always it is at most 3. Example, here if the pattern is like this, plus 1 plus 1 plus 1, then the number of additions are only 3, correct? In that way, so finally number of operations will be reduced. That's why it is faster algorithm than your Booth algorithm. Okay, so remember this stuff, it is more than sufficient. Whatever I taught, you just remember it. Okay.